Hello and welcome back. Factorizing quadratics on the menu today, but not as you expected. It's a little bit of a twist in all of this. By the way, I spelled the word factorize with a Z, so please do not bother me with spelling errors. I'm a Z man rather than an S man. Okay, let's have a look at this. Of course, we all know how to factorize that. This is an x and an x. It says 6 times 2. Is 1 plus and 1 minus, the minus on the 6. So it's something like that. But I will come back into that in a little while. So that's the first example. But I haven't quite done what I wanted to show you here. Of course, we can, this is so dead easy. You might be wondering, what can I do to actually show you something new perhaps? Okay, let's have a look at this one. X squared minus 4x, let's say plus 1. Okay, this doesn't factorize nicely over the reals, although it does factorize. So a lot of us, myself included, when I was a lot younger, I will use the quadratic formula, but that is cheating and it's very, very soft. It's not really for the mathematician. So how do we factorize something like that properly? And when I say properly, I mean properly. Okay, here it comes. All right, let's follow the workings. X minus 2 all squared. Minus 4 plus 1. I just completed the square. There's no two sides to move all of this to the other side. This is just that is equal to that. So what do I do next? Well, quite clearly, that is still equal to x minus 2 all squared minus 3. So now what? Well, it's the obvious thing. That's a difference of squares. So this now, I can write it as minus the square root of 3 all squared, difference of squares, and now it's done. X minus 2 minus the square root of 3 multiplying the bracket x minus 2 plus the square root of 3. And I'm done. So this is now factorized. Not a side of the quadratic formula and making up equations that don't really exist or anything of that sort. So let's go to another example and say, okay, what about if you have something like this now? X squared plus 6x. Let's make the constant term a little bit big, but at least let's make it something nice so it does work nicely. Plus 18. Okay. Put into two brackets, no problem. X plus 3 all squared. So we're completing the square. Minus a 9 plus 18. But now we have, of course, a problem over the reals because, of course, in this last example, I completed the square and then I had difference of squares. So now what do I do with this particular one? Well, I said over the reals, but over the complexes, I can still write it as a difference of squares as follows, of course. Minus 3i all squared. Just check that it does work. When you square this quantity, the I square will go to a minus. Times the minus gives you the plus, and of course that's a 9. Okay, difference of squares again. X plus 3 minus 3i and x plus 3 plus 3i. Can we make it a little bit more challenging than that? I guess we could. We can stick some i's within the starting equation. So this one, let's say, and I hope I don't get too difficult numbers with this, x plus 4 root 3i, and now try to think of nice numbers. Negative 9 should be okay, I think. I say. So let's have a look at this one. All right, we're going to put into brackets. Okay, x. Oops, I didn't put an x in there, so I'm quite stupid really. I just was concentrating on the coefficients. So let's put plus, let's stick it at the front, actually, plus 4 root 3 xi. So we have it like that, okay? So, two brackets, not two brackets, sorry, I beg your pardon. Completing the square, x plus 2 root 3i all squared. Minus, let's put the extra lines on this one so it doesn't go wrong. So minus 2 root 3i all squared minus the 9 that we have in there. Do a little bit of a tidy. X plus 2 root 3i all squared. Now, the I, when it gets squared, it's going to give us a plus because we have a minus at the front. So it's a plus. And squaring the 2 root 3, that's a 3 times 4 is a 12 minus a 9. So tidy that further. X plus 2 root 3, I plus, oops, I missed the square there, plus 3. I need the difference of squares, and again, I have a plus, no problem. I can do it over the complexes. So I'm going to write this as minus the square root of 3i all squared, just checking that it is exactly the same thing. The I squared gives me the minus 1, times the minus gives me the plus, and of course that's my 3. And now again, I have difference of squares, x plus 2 root 3i, oops, I missed the other bit, minus a root 3i, and then we go x plus 2 root 3i plus root 3i, which of course will simplify further to the bracket x plus root 3i, that's this bracket here, multiplying x plus 3 root 3i. And we can actually check that. It's not actually that bad to check. There's my x squared, root 3 plus 3 root 3, lots of xi is just there. I just need to check that this indeed is a negative 9. So we have the I squared will ensure the minus, and then we go root 3 times root 3, which is 3 times 3 is indeed what we wanted up there. And just returning back to that, of course, for something like that, we'll put it straight into brackets. It does factorize by inspection, but can we do the same thing for this particular one? Of course we can. We can actually complete the square, x minus 2, all squared, minus a 4, minus a 12, which of course will now give us x minus 2 all squared, minus a 16, which of course it's a difference of squares, and that's a minus 4 squared, which will give us x minus 2 all, oops, going absent-minded right at the end of this video, I do apologize. So this is now an x minus 2 minus 4, x minus 2 plus 4, which of course it will give us that. And I don't suggest we obviously do silly things like that for such a simple example, but if you need to factorize any quadratic expression, the method that I've just shown you is actually quite a powerful method, and I hope you followed it. If you're doing straight maths and you haven't seen complex numbers, I hope you actually followed what I'm just doing from the example that I just shown you in there, and how to manipulate it in order to put this into 2 brackets. Okay, I hope you find it educational, and I'm signing out. Bye for now.